welcoming Professor Yogesh Kumar Meena. He is an assistant professor of computer science and engineering at IIT Gandhinagar. He received his MTech from IIT IIM Gwalior and PhD in computer science from Ulster University. He worked as a senior AI software development engineer at University of the Essex and Mesra Homes Limited. Professor Yogesh Kumar Meena has been honored at the Distinguished Alumnus Award from IIT Management Gwalior. His research direction mainly on delivering intelligent technology system and transforming community and healthcare. He leads the lab of computer science, human and interaction lab. Please let me.
Okay. Can you hear me? Everyone at the back? Okay. Thank you, Rishabh. Thank you for the introduction. So, in today's session, I'm going to cover the accessibility interface and emerging market. So, before going ahead, there are the few things which I just wanted to confirm from you, and then some keywords which we should familiar about it. So then it would be good to explain the techniques, methodologies behind that to understand the development, to understand the process, and to understand the usability of the AI in this domain. Okay. So the first things, can you please tell me what are your background? So like in computer science, electrical, or if you are from the engineering backgrounds, or so how many of you are from the engineering backgrounds here? So how many of you are from computer science? Okay, okay. And other non-engineering background students? Physics, okay. You? Mathematics, okay. Rest of are? Some people here, some people are from the humanity or some social science background? No, most of them are from the engineering backgrounds. Okay, good. And most of them, I would say the maths background. Okay, correct. So I think then I can go in the depth to explain the concept in that way. So in accessibility interface and emerging market, first, like, we should understand, and maybe some of you already know. So please tell me, like, what does it mean by the emerging technologies? So when you see these titles, what you thought of, like, what kind of the work is going to present by the professors or the faculty during this course? There was any thought on this point? When you see first time this title, what you thought about it? What I'm going to consider, or topic, or some things which you thought about it? Anybody can, if any idea? No? What you thought when you see this title of the talk? Yeah, please be interactive. Like, don't think like I will just throw some things. So we should be interactive, and that is why, like, I prepared the 2 questions to ask you. Yes, please go. Yeah. Yeah.
Yeah, we can say that robotics, automation, AI, like this.
Robotics, automation, AI. Not exactly, but like AI is wherever we talk about like computing devices. So AI is there, correct? In some sort of the analysis, some sort of the application to actuate the things. Okay, but any other idea? Yes, please.
Potential for some technology to develop like its user basis.
Yes. So, but not only the user basis. Yeah, that's good. So like if I understood correctly, you are trying to say the usability perspective, correct? Yeah. So I think you both are correct in some sense, but let me introduce the things like emerging technologies. So what does it mean by the emerging technologies when we talk about it? How the technology can be designed, which should have some sort of the potentials or innovation in the early stage of the deployment or development. So what I meant by the early stage of the deployment and developments, you may think this technology could help people, maybe it's not mature enough at that stage, but it has a potential to serve as a key technology in a longer run. So that is meant by the emerging market. So if you talk about the lots of these emerging technologies in terms of the AI, in terms of the computing, in terms of the machine learnings, so emerging technologies have a lots of potential to serve the people, not only to do the research perspective. Okay, so that is the emerging technology concept. Okay, so in a various aspect, which could be the a societal aspect, industry aspects, or everyday aspects. So like you can understand this summer school, AI for social good. So like if some things which we are developing, which could be have a societal aspect or societal impact in the environment, impact for the society. So that is the emerging technologies, any technology which you are developing, which could be in that direction, correct? So let's come to the other terms which I use, the accessibility. So let me say accessibility in computing, or SCI. What is SCI? Is human computer interaction. Okay. So what does the accessibility mean? What do you understand by the accessibility when somebody says the accessibility? Is anybody? Yeah.
Something that is usable by everyone, or it is very easy to use or easy to acquire, access that technology. Okay? No matter where I am or who I have some, I am able to access it or use it.
Yeah, exactly. So now, yes, you are right. So inclusive for all, correct? If we are designing something, doesn't matter the technology, prototype, product, it should be inclusive for all. But how we can see whether it should be inclusive for all or not? So let's say if you design a technology in perspective of the some of the particular user set, which could be the elder user, but can it be accessible for the people, those who are not the elder, those who may be the disabled people, those who may be the children, those who may be the aging people? So how we can define the accessibility? So when we are designing, we should understand the importance of the accessibility in the technologies, correct? So, and accessibility is also called like this terms in a interaction design. If you can see there is a very good websites. If somebody want to see the IDX, is called the IDX, where you can get the lots of contents for usability or interaction design things if you want to learn more in that domain. So accessibility, also known as it's not read like A11Y. It says accessibility AY. Okay, so this is also somewhere in the government policies. You will find this A11Y. So what does it mean by that? So this is the accessibility. So whole word is read as accessibility. So in that way, design and development of the system, software or interface, whatever we are developing, including the AI, without AI, rule-based, whatever we are doing. So that are usable by the people include those with a disability or those who have some sort of the impairment. So like visual impairment could be auditory impairment, motor or cognitive, correct? I will go in depth later in this slide. But that meant by the accessibility, how the technology could be, like let's say this room. So you all come here, but let's say if a person who is using the wheelchair, how he can sit there? So whether this room is accessible or not. And if it is, then at what extent it should be accessible. So, so that kind of things, it's not only the technology, but whatever you are doing, you should think about it. So one of the example, alt text, everybody know the alt text, to see the like text of the images or the web. So, and this is, I think, in digital content, this is a very prominent field to work on. So, all text, like if you can, there is a tool. So, scan the image, which will give you the information text of the image. So, let's imagine if some people are having some sort of the disability, those who cannot see, visual impairments, then how they can read the websites. So if every image or website shouldn't include such kind of a feature, which was there is a tool from the Microsoft, Google, so you can use, and there is a like Chrome based tools to see that. So you can do that kind of like how you can identify whether this accessible website or not, accessible tools or not, you know. So then you can check and you can modify that by the tools. Okay. So this is just one example. But let me come back, like one of you explain the usability perspective. But this is the difference between the, when I talk about the accessibility and usability, both are the sisters related to each other, and UX is just a part of the intersection of that. Okay, so when I say the accessibility, then different kind of the accessibility which will matter, and I will explain you what I'm considering in today's lecture, but this is the umbrella term. So I thought first I will explain, then you should understand the broader perspective of this. So when I talk about the accessibility, like validation of the tools, if when we design these standards, like W3 schools kind of the standards, so it's a Web3 standards which we need to design. Accessibility technology or assistive technology. So how the technology can assist the people, those who are having some sort of the impairments. Okay. And then access to content and legal requirements. So these all things come to the accessibility when you will see somebody is doing the research or some work on that direction, and these all are related to social good. So in today's talk, I will broadly consider the assistive technologies. Okay. And I will explain you what are the input modalities which we can consider to design the technologies for everyone, or inclusive usability of them, correct? And in other hand, so usability, so when we design the technology, then one perspective, we first design and ask user to use. Other perspective, we put user in the loop while designing the technology, like a kind of iterative process. And then we design by taking the feedback from the users, and again through the usability studies we can evaluate the technologies. And it not only just a software, it not only just for the tool, it can also use to evaluate the AI models. It can also use to evaluate the technology which are using the ML and AI concepts. Okay. So this is the, and UX is a part of that. So like good UX should have a accessibility and usability both. Then we call this is a good UX. UX is not like kind of the user experience is not kind of just a interface which we see. It looks good, you know. So most of us, we believe the interface means aesthetically pleasing environment, correct? But it should have these things behind in that. Okay, this is clear to everyone? Okay. So now, what are the accessibility issues you could think of, like exist in the research, exist in the society, exist surrounding to you? So what kind of the issues you could think of? And therefore we need to work on to develop something towards to that direction. Anyone? Yeah. Yeah. In what sense the public transport?
If I start from buses, like the first means of public transport, some of the buses do have ramps, but most of them are not used in such a way that the ramp can be used. They're filled with people, they can't. And in bus stops, how the person will know that what bus stop they are in?
Yeah. So in order to understand this perspective of the differently abled users.
Yes.
Correct?
Yes.
So the users could be, accessibility issue could be related to the vision.
Vision, yes.
Correct? Like kind of the different modalities.
Yes.
Hearing, all 5 senses, I would say, in terms of the cognitive and neuroscience perspective. Correct? So yeah, so like visual, so the problem could be color blindness, mobility issues, like as she was explaining, but it could be with the wheelchair concerns, let's say. Auditory, hearing difficulty, seizures, learning cognitive, like a dyslexic users. So now coming back to, I just wanted to conclude this, and this figure is from the IDX, which I took, like interaction design platform. So it's a accessible design for everyone. So when I say accessible design for everyone, so this could be like, which could be the cognitive and learning disability users, blindness, speech inputs could be used, hearing impairment, motor and disability. So now we need to think about it, because for the user perspective, how the technology should be designed and how the software hardware integrations with the rule-based algorithms, with the data-driven models, how we can implement in terms to design the solution for them, correct? So let me again just one motivation and why this matters. So I think after today's lectures, you will think like why this matters, like not just for the interface design, but why this matters. It means like, if you see, and this is the WHO data, if you open just a WHO website, I just took today to this first. So estimated 1.3 billion people, 1 in 6 people worldwide experience significant disability. And this disability could include the mobility disability, physical disability, so like different kind of the disabilities. And also Census India 2011 reports also reported such kind of things. So if you want to go in depth, you can check. So but coming back to this, so why this matter? So person with disabilities like have the poor health experience with the more limitation. So how we should design a technology which may help them? Let's say we are, that is like, I'm using the terms here, differently able. So because like in terms of the, if you are saying somebody disabled, which is not right term to say the disabled, correct? So differently able or person with disabilities, that kind of terms you should use. So like in somewhere you'll find these things very legally accepted or not. But so what I wanted to say here, so how the technology can be designed which could satisfy someone's needs, and based on that need you can use the different kind of the hardware, different kind of the software, different kind of the model, and then you can design the technology, and that could be fulfilled. So when I'm saying the design the technology, then in this accessibility interface, if somebody want to work on or working on that directions, so like this could be like, there are the lots of technologies available. I'll come back to them that after this slide, and then we'll start what are the challenges in them, and I will present you the some of the solution, and then I will end up with the some of the directions, innovations which you could think of, or which you could do that. So when I'm saying accessibility, that can enable user disability to interact with the system. How? Like screen readers, for example, through the different modalities, where one could have at least quadriplegia, like all arms and legs is not working, but still their eye may remain intact. They can use the eye so hand-free control for this, for example. Brain signals. So there are the logged in patients, like, so they can use through the thought process, how you can talk, how you can, so like the best example you can think of is Stephen Hawkins, correct? So, but I will, why the technologies which Stephen Hawkins can afford, can we afford that technologies? Can the low resource settings users can afford their technologies? So therefore the research will matter, correct? So because like what I meant by the affordability in terms of the cost, also in terms of the resources required to run their technologies, in terms of the assistant required to run technologies, correct? So affordability. So there are the different haptic feedbacks which controls which we can use to design the different kind of the technologies. Any doubt till here? So this is just like introductions which I put in a frame what I'm going to cover. Okay. So now in SOTA, like state of the art technologies. So as I explained in today's lecture, I will consider accessibility as assistive technology is just one terms, and then present you the some solution and methods, which is a AI or non-AI also. So in assistive tech for the effective communication and mobility. So what I meant by the effective communication, it means those who cannot speak, like has a speech problems. So how they can speak, okay, and or maybe somebody those who have, I will cover in the challenge like those who have a slurry of speech, this kind of the like it happened after the operation of the tumor also, sometimes when the brain connection may damage, okay, and how it can be rebuilt. So for such kind of the users, mobility like wheelchair kind of the things, how it can be enhanced in terms of the current settings or requirements of the users for the low resource settings. Okay, so in a ARC systems, so when I'm saying the ARC systems, which means it include the large set of the gestural, alphabetic, you can see iconic communications. So these all the technologies are available in the emerging market, like commercial markets, correct? And other way, if you can see the wheelchair, so wheelchair is commonly used assistive device, which you can say for the activity of daily living, where people can use like for feeding, toileting, and dressings and grooming and so on. Okay, so but what is the current limitation in these technologies? Okay, and how we can design a solution which can be more innovative or maybe more refined version for that. So when I was talking about the mobility challenge, then I'm going to consider this mobility challenge, and typically these are the mobility challenge. So like physical mobility, for example, and in physical mobility, if somebody have a spinal cord injury or muscular dystrophy, stroke, so how they can use the technologies to do their activity of daily living, correct? So here I'm talking about the just for the daily living activities, not the other. In the other hand, like these technology can use for the rehab also, okay, but I'm not considering. If I will get a time, I can show in today's lecture. If not, then I will cover just for the activity of daily living. Then dependence on the assistive device. So like wheelchair, walkers, and other assistive devices are often necessary for basic mobilities, correct? So environment barrier, physical barriers like so stairs narrow. So when you are designing the wheelchair, then how it should tackle that. So in terms of the like how it should tackle that, it means when I'm going to integrate that with the input modalities which I have explained to you, like input switch like a gauge or like a brain switch or some other kind of the haptic feedbacks, then how it can tackle. Communication, it means like when we talk about then condition like aphasia, dystrophia. So these are the like speech problems, like when the user have such kind of the problem, then slurry of speech or their neural connection may damage. So how they can convey or how they can talk with the people in an intelligible way, correct? And also it could be like to use the ICT like in education technologies for their activity of daily living, of course. Limited vocabulary or non-verbal communication. So these were the majorly communication and the mobility challenges. So now I will introduce you the all the terms in terms of the input modalities I have explained, and then we will cover the fundamental aspect of using them in the practical life. Okay, so technology and accessibility interfaces. So first, like, let me introduce what is this, what is happening here. Computer reading brain. So like, so this is like the brain signal is coming and then going through some of the device, and then in the computer you are visualizing what is the signals, correct? So it means like this concept is called the brain computer interface. Okay, I will explain in detail. So how BCI can use? BCI can allow someone without the use of their hand to control the computer through the thoughts. Okay, so in brain computer interface, to control the thoughts, our brain areas depend on the motor cognitions, visual cognition. So I'm not going to consider, I think you will be having the BCI lecture, but I'm considering all the fundamentals. So maybe you will see the more advanced things there. So this is the typical pipeline of the brain computer interface. So typical pipeline, it means like in a machine learning model, when we use for data acquisition to the classification. So let's say here in this case, this is for the classification. This is not a regression model. Okay. So classification, it means like if you want to take two different class of the signal, let's say motor imagery. So you can think of imaging the left hand motions. You could imagine the right hand motion, and then you can quantify whether it was a left hand signals or right hand signals, and implement lots of different algorithms to do that. So in a way, like for feature extraction, there are the different methods how you can separate the features and what features you are required in terms of the, like when we talk about the BCI. So you have a different activities. So the range of the activities. So when I can give the one example, when I'm talking about the motor cortex or motor imagery signal, then mu and beta. So mu, it means like the frequency of the signal is between the 8 to 12 hertz, then you can extract the features from there. And beta, it means like frequency of 12 to 16 hertz, then you can extract the features, and which is related to the motor cortex. So which is already known and given in the previous research. Okay, so like that you can do, and then once you can classify, then now it come to the pictures. If you classify, then you can do. So through the brain, you can send the signal to the crane machine. It can lift the some item. You can. This is a 0 and 1, like when we write the program. So you can send the signal to actuate something. You can send the signal. That signals, if it's A, then it should be click. It should be type. So whatever application you want to build on, you could think of, correct? And that feedback can be go to the user, and user is in a loop. He is seeing, like through the thought process he is controlling. Okay, so this is the typical brain computer interface pipeline. So mainly this is useful for the totally logged in patient. So what I meant by the totally logged in patient, it means like even they cannot use their eye. So but still their brain is active, correct? They cannot use their body part, like but they can think. So how they can communicate? So BCI could be the one of the great modalities for them to communicate in an intelligible way, correct? Quadriplegia patients, it means like hands and feet are not there. Healthy people also, it's not. So nowadays, like the most promising directions for the BCI in the gaming. So you could use for the different games, and how it can be integrate with the games where some signal is coming from the brain. So instead of like multimodals or some hybrid models which you can design to play that kind of the activities, correct? Similarly, so in this, like when I was talking about motor cortex, so here you can see So motor cortex is this. So the signal from the MI, which will be in motor and somatosensory cortex. So like this is the center part of the brain, where, and some signals come from the prefrontal lobes also when I talk about the motor imagery. So motor imagery could have a maximum of the 4 classes in the any system. So what could be the 4 classes? Class 1 could be the left hand imaging or motion, like a moment, right hand and tongue and both feet. So it could be the 4 classes. So if you are designing, then you can use the 4 class to develop the interface or develop the technologies. Whereas there is the other BCI technologies, modalities, I would say. So like SSVP based, where you can just flicker some images and look at there. So, and you can do the actions, for example, to type, for example, to write, like a keyboard. And P300 speller also there. So when you are focusing on some, if peak is go to that level, then it can be actuated. Okay, but here I'm going to consider the motor imagery, and this is the like how the channels can be placed. So this is the like non-invasive. So like you should wear the cap, and then signal can be recorded from the surface. So in a current research, like we do have a both like dry electrodes where there is no gel is required, but gel based electrodes also, so where the gel need to be put in that to record the brain activity signals. Okay, so other things, accessibility interface could be the eye tracking base, where similar way it allows someone without the use of their hand to control the computer through the eye, as there was the thought eye movement. So typically, if I go to the typical pipeline of that, so, and I will show you the some of the models which in a Hex lab we have designed, my student has built. So with the perspective of the gauge based cameras and without like VZ cameras and things, so which can be possible by help of the AI. Okay, and so here also in eye tracking things, if you talk about this, so what we do have, so the camera which will give us the projector or illuminators, where you can see the kind of the create pattern on the infrared light. So if 2 IR cameras, so it depends on the what kind of cameras you are using, then you will get the more frame, and like it depend on the frequency of the camera. And then here they take the high frame rate image to user eye and pattern, and then pre-process the like by using the algorithms, you can pre-process whether this video to image and image to XY coordinates you can decode. And if you have the XY coordinate, you can do whatever you want. So like you are the free bird to interact with the computer and develop anything. Okay, and then you can integrate with the application. And similar way, it can be used for the people, those totally logged in patients, but those eye moment may remain intact. So it means not totally blind. Okay. Other technologies in the commercial markets is like single switch hardware device. So I'm just giving the familiarity of these things. So it's called the like sniff and puff kind of the switch, soft switch. Like let's say if somebody has a less mobility in their hand, so they may not use the mouse to press that button, but if they can use the kind of the soft switch which require the minimal residual power to just press it, and which can be pressed not only by hand, which can be pressed by feet, by mouth switch, by tongue, you know. So there are the different kind of the arrangement you can make it. And whereas these kind of the switch, like if let's say I'm using this switch here, it can be plugged with the, and there is a predefined commands in this. So it means like if it can be plugged in the level 1, then level 1 we do have 5 commands. 5 command, it means like the you can set on the enter, then when the switch will press, it will work as a enter. when the switch will press, it will work as a. So like you can make the modalities that way according to the need of the users, correct? So other accessibility interface and technologies, which is like electromyography, which has a both surface level and then intramuscular EMG. So surface EMG, it means like arm bend. Okay, so you can use the sensors on the surface level, and then through that you can detect the EMG or different kind of the gestures of through that. So like let's say if you fist open, fist close, so through that you can detect and you can actuate the technologies, and there are the different work. So like recently I think Meta is working on air surface detection kind of the problem, so you may check. And in this intramuscular, also inside the EMG electromyogram can be recorded. But let me, so now, and this is the based on the current research till now, what we have done in a Hex lab. So what are the current challenges in these technologies? So majorly I'm considering for the eye gaze tracking and a BCI. Okay, so in eye gaze tracking, the challenges is still now, doesn't matter you are doing with the camera or you are doing with the high efficiency of the eye tracking device, but challenges the Midas touch problem. So what is the Midas touch problem? So Midas touch problem is it means like if you are looking at the screen, some of the let's say button, so how your intention, whether your intention to select that by looking is correct or incorrect. So how you can how you can see. So sometimes we don't want to actuate something, but we are looking just to see that what are the options, but how we can handle that kind of the problem. So it happened due to the involuntary eye movements. So involuntary, it means like which is not in the action. Okay, so dual time issues. So let's say I will give you the some of the solution for all these problems what we have built on so far. So dual time issues. So dual time, it means like if let's say a user A who can use the 1 second to focus on the particular key on the keyboard and then can type, correct? So user A may be very good to focus, but let's say user B who cannot focus for the 1 second, he or she, they need the more time, or they need a less time kind of, correct? So how you can design a system which can adapt based on the user behavior, based on the user patterns. So it's called like adaptive kind of the algorithms or things which need to be think for the dual time. So what is the best dual time for the persons? So dual time, it means like wait time in a gaze tracking, where you need to look at that particular fixation points to select that item. So it could be, you can define just timer. Frequent recalibration. So let's say you did the calibration with the one user when you are going to use the application, but for other user, because of the setup, the calibration need to be done. Then how you can solve that kind of the problems which the system is not requiring kind of the calibration, correct? Accuracy of the detection gaze coordinate. So best accuracy in terms of the, if you are designing the regression based models or you are designing the classification based models, how you can solve that kind of problem. Whereas in BCI also is like setup, because it required the more time to set up. So now there are the systems which require the less time, like a dry electrodes kind of the systems, and there are some caps you can wear and walk kind of the systems. Okay, so but it says the lack of the sufficient higher accuracy, reliability, low information transfer rate, and then user acceptability. Low information transfer rate is like how accuracy in terms of the BCI. So we calculate based on number of classes and accuracy which you are getting from the classifier. Okay. So let me now let me give you the sum of the solution. Then you will see like something what I'm talking about it. Maybe I'm talking in the air. Okay. So let me put some solutions here. Then we can go ahead. So one issue. So let's say number of the commands or ITR. The issue which I explained in the hybrid in the brain-computer interface, and the other issue I have explained the Midas touch problem, which are involuntary eye movements. How we can solve that by designing the hybrid gaze and motor imagery based system. So it means here you can see. So what are the challenge like command choices which were less? As I say in a MI, we do have only the maximum of the 4 class. But again, for the classifier based models, it's difficult to see the difference between these things. False positive rate of the eye tracking, designing the natural interface, and frequent recalibration of the system. So therefore, the hybrid BCI combined the ERD. ERD, it means event related desynchronization BCI and eye tracker, and where we develop the approaches for the gaze tracking and feature extraction classification. So let me first show you the model, then I think, yeah, you can see here. So when I'm saying for the development, so here you can see the solution. So where we have a gauge, so eye tracking, where I can use the gauge to search the points, and due to the involuntary eye movements, I can use brain to validate that. So let's say I can look and then think through the brain whether I want to execute that. Correct? So this is the models where through the gauge, what parameters which we are getting, the XY coordinates and the time when we are recording all the 2 systems, and from here MI like motor imagery labels, whether it is belong on the left or right hand moment, and then time and label, and we can combine. So we can get the all the information in this array. So now this model is you understood what I'm explaining, how we can resolve that problems by designing this. So what we did the study for checking the how the class can be improved in 2 to 4, 4 to 8. So because like if I'm using only the BCI, then 2 classes. But let's say, and why this study is like number of classes, because let's say if I want to control the mobiles or if I want to control the speller, then I need a more classes. Otherwise, to go to the n level of the tree, I may need a 5 step to go. So it means like the accuracy or the speeds will be very slow. Then still we are saying this is for the user with a differently able user, but system need to be fast, correct? So then here in this paradigm, we did like when you do have a ideal state, then what was the experiment I'm trying to explain. So we take the 2 class, so left and right. So in the screen you can see first one. How many of you know the congruent effect? Anybody heard about it? Congruent, incongruent, no? Okay. So this is the in this we wanted to check. Let's say if I am holding this cup from this cup is on my right hand, I'm holding from my right hand. But let's say if I'm holding from this hand, then this is the incompatible for me, but this is the compatible. So this is the congruent effect in the layman. Okay. So then for 2 class of the BCI, in the experiments, when the left will appear on the left side of the screen, you need to think for the left. But when the left is appear on the right side of the screen, still you need to think the left. So the cross modalities. So and then through the gauge you can look at that particular point. Okay. So it means like in an experiment, it will come at the 4 places. So we do have a 4 gauge classes, like 1, 2, 3, 4, and then 2 of BCI classes. So it means like we can increase the number of command 2 to 4 if we can 2 into 4, correct? Then how? Then we did the experiments, and then I will share the results with you in that sense. But before that, like this is the typical pipelines of the analysis of the data, gauge data or EEG data. So in gauge data, we can get this calibration, and then based on in the calibration, you will get the X pose and Y pose, what were the actual during the calibration, and then what was the projected after that, okay, and then you can find the accuracy of that. And similarly, you, as I was explaining earlier, you can use this is the band power features for the which is related to the motor imagery, and then CSP is used to separate both the features. I think if some of you did the work in the machine learning, then you may aware about the how you can separate, okay. And then these classifier were used to classify that pattern, okay. So whether this is belong to the left or right hand classes. So, and when I was explaining the information transfer rate, because like here now we are fusing the 2 different technologies, then this is the terms to give the accuracy. So, but how we can define that accuracy, because one signal is coming from the gauge, one signal is coming from the motor imagery based BCI, then how you can fuse. So here this is based on the if you want to go in the depth and want to understand this is based on the Shannon theorem. So based on the entropy and Shannon theorems, you can understand, and this was the given by the Walpole. So here we can see what are the number of the commands. So n is the total number of the commands in the systems. So let's say for the gauge, if I'm going to do that, so for gauge, what will the total number of the command? Maximum of the 4 command. So you can take that, and B is the accuracy which is coming from the classifier, and that way we can fuse and see what is the information from like bit per minute. So how many bits the system can transfer when, so it means like let's say the speed of the system. So how we can measure that? Letters per minute. So similarly ITRs can be bit per minute to how many bits are transferring doing that. So through that we can see if this higher, then speed is higher, okay. So this is like a gauge estimation. So as I was explaining in target points, so this was the actual points in the calibration, and this was the after the calibrations you can see for the particular user. And let me, yeah, here you can see the results. So these were the for 4 classes. When I was explaining, left will appear on the left, all 4 corners, and then here you can see 1 to 4 is a classes of the gauge, and we put the what are the XY coordinates during the whole experiments over there, which you can see here in the like map points, okay. So this give the accuracy above the, still some of the like these points were very scared, but when you combine the mean, it would be like above the 90% for the user to detect that particular. Because why? Because like here you are seeing the center points, but in the box we detect the whole the box, correct? So center of that. So now the concept which was like how we can increase the command, so build the concept of that, what the accuracy trade-off would be. So let's say if you want to do this 2 command of the EEG, 3 command of the EEG, 4 command of the EEG, and here the accuracy of the BCI eye tracker command. So let's say we use in our case 2 in previous, but we give how you can increase the command and how the trade-off the accuracy can be achieved by increasing the command. So therefore we have shown that like this trade-off, this much of the accuracy can be achieved to design any kind of the accessible interface. So this can be used in that kind of the interface. Okay, this is clear to everyone? Any question? Okay. Okay. So now from that study, I would put in this way, from that study we took takeaway. So like we already know now if these points can be selected through the eye tracker, if these locations are easy to detect, correct? So we took that perspective and designed the virtual speller. So now how the real-time applications for the users, which we are talking about it, like mobility or a speech user. So we designed the speller, and so far like in my lab, like we have designed the 5-6 different languages speller in that way, and put the different kind of the input modalities with them, different algorithms to improve their performance. So one solution I will put here, and what this like will do this, like it will solve the problem of the adaptability, practicality, and as we are discussing earlier, it's like the adaptation to the user. So we designed the adaptive multimodal virtual keyboard for the alternative and augmentative communication for these users. And so in this, like now why I'm saying interface, so because like interface was designed to validate these methods. So the idea behind the work was to design the adaptive methods, non-adaptive methods, and different mechanism, and then prove by designing the one application, integrate all the methods with that application and test with the users, correct? So you can think about it like when we say accessibility interface, then interface means just not a UI, okay? So like, so in here you can see. So now let us try to understand the overview of the gauge, working modality of the gauge I have given you earlier, but how this work in, and this work in the different kind of the mode, and which I just wanted to explain you. So gauge based access control can be done in the two different mode. One mode could be the asynchronous, another would be the synchronous mode. And what does it mean? And similarly, BCI system is also work as like that. And what I meant by that, so let's say, and why we did this, because some mode is useful for the some particular application, other mode is very good for the other particular application. So in asynchronous mode, it means like a user do not need to wait. So it means it's a self-face kind of the interface in the real time. So user can look, and then whatever the dual time you are putting, it can select based on that, okay? So here I will, here in this you can see. So earlier I was talking eye gaze plus BCI, but instead of the brain computer interface, here first we work just with the eye, because eye signal gave the highest accuracy. Then not just for technology, not just for sake of purpose, oh this is using the brain, so we need to use the brain to fascinate these things. So we thought like what would be the commercial usable for the users, so just one input modality is here first, and then we use the other modalities also. So in this, search can be done through the eye gauge, like gauge camera, and select can be based on the delta t, which is the dual time, in the which could be the dual time, and in synchronous asynchronous mode, and it would be the trial time in synchronous mode. And what does it mean by that? So trial time, it means like when I was saying the user have a problem with Midas touch problem. So then it means like if you did the false look at some points, still your selection is not going to happen in the synchronous mode. Why? Because we are in synchronous mode. After the completion of that trial, you can revisit, and then based on the weightage or based on the parameters which you are setting to the algorithm, it can be selected. Correct? So this is the main difference between both of them. So let's assume in a system. So I will give you the now some methods here, and I think you should understand that. So let's assume in a system we have a m number of the commands. So earlier we used only 4 to 8 commands, correct? Let's assume m number of the commands, and then in here now we have a x and y coordinates. We'll get through the I gauge. So we use the just this distance formula. So like y, we use that. So let's say if you have a UI where you have a 5 or 10 buttons, then if you are looking, let's say in both points, if you are looking in between this, where is my pointer, let's say, then let's say this box and this box you want to select, then which one will select? How you can give the weightage? So what we did, so one thing, if you are looking inside, then definitely it will, you are pointing to select. If you are looking, definitely you are pointing to select. But if this is in between that, then we define based on the Euclidean distance, which is the minimal distance from that box. Doesn't matter if I'm looking at here, the distance will calculate and it can select automatically. So because our idea is to actuate the interface, correct? So the Euclidean distance can be used to do this kind of things. So let me put this. So what is happening here? I think it's a simple algorithm. So we are doing, and I will show you the demo of this also. So you will see, you will relate everything. So here in this you can see, so we have a time t, we start, and delta t is an incremental times which we are giving to this. So what we are doing here, all the commands, as I say, 1 to m. So arg mean of that we are calculating, and based on the timer which we are here, if the select t equal to t minus 1, then we are increasing this, and this is not for the selection, this is for the updation of color. So let's say if you are looking at some button, then how the user know you are there. So we have implemented the how the like the border color or button color will change from less darker to high darker. Okay, so then, and then based on that, if that command is belong to this delta t time, so what is happening here, just you need to look at this for this delta t time through the any commands, and then once it will reach, it can select, correct? This is simple asynchronous mode algorithm. Whereas let me talk about the gauge based interaction, which could be the synchronous mode. Then in the synchronous mode, as I was telling you, this is delta t is a trial time. So it means if you are having the multiple commands, then the selection will happen at the end of the trial. Then what we did, so what was the weightage? So let's say if I look 1 second here, 1 second here, 1 second here, and then what was the weightage of the, and I can revisit again here, I can revisit again here. So after 2 seconds, it will calculate where my maximum focus was there, which is impossible by the delta t, and then based on that, your selection will happen. Correct? This is clear to everyone. So it means you are like, you can come from that desk to every desk, and then we can calculate the time where you stayed longer, and this can be selected based on the parameters which we are giving to the model. So this mode will help user to reduce this kind of the like in eye tracking Midas touch problem. So involuntary eye movement. So it means like if you don't want to select something, but you are moving here and there, then that weightage is not going to count at the end of the selection, because maybe this is not voluntary, you want to look at there, because our eye fluctuate very fast. How many times our eye fluctuate in a second? Anybody know? Okay, you can check, do the Google. So, and what is the frequency which our eye can see? Okay, you can check that. I will leave to you. Around? Yes, yeah. 24, around 24. So therefore, like that is why I was not giving this information to you, but now it. Okay. So therefore, like because now it will take my 2 minutes to explain the other thing. So if you see this kind of the gaming environment where you see the image is going forward very fast, and then displays is also come, they have a what is the frequency of this particular display, so which user can see, correct? So therefore, like frequency will matter when you are designing that. Okay, and also like we see in the when we see the 3D images, 3D movies in with the glasses, why not without the glasses you can see that kind of things, because our eye frequency. So let me come here again. So then this selection, we understood the synchronous, asynchronous. Then now there was a one problem, interesting problem which we have found, like in a user. Some user is very good for the some particular time. Then we have tested the systems we designed with the 1 second to the 5 second different users and found out like this is the best time which can be used for the in static time, I'm saying. But static time is not good, so we have developed some methods, some rules for the asynchronous and some rules for the synchronous. So rules, it means like some of the, if in a rule 1, let's say n character, so number of the character in the history, if it is greater than the epsilons, what the times which we are giving at the beginning, so it means the system is starting at the 500 millisecond, correct? And then I'm starting at the 500, and then it can go up and down. So if number of character in a history, it means like user is making the mistakes, then it means the dwell time need to be increased. And other way around, the other rules which we make to the systems. If delta t time is less than the epsilons, then it means like user is typing very fast. Then it means decrease the time. So based on the what user is typing, we can check in the history number of the letter is typed, and then adaptive rules which we have made. And similarly, we make the 3 different adaptive rules for this synchronous mode. And what they are giving now time is user system can automatically define. So like sometimes if you are typing very good, then it means your system will decrease the time. If you are making the mistakes, and how we test it, I will present the results and then we'll see. Okay, this is clear. So if somebody is thinking to work and that, then this could be the like algorithms and other methods also you can incorporate. I will present some other things also. So now that was the like typically how the gauge based interface will work. Okay, now we did with the command selection with the single modalities and command selection with the multiple modalities. Then in the single modalities, like because these two is a baseline, so where mouse was used and touch screen was used. So let's see if user is using only the mouse and then using touch screen versus these different input modalities to see the interface performance. And here in this, we develop the systems where eye tracker and soft switch, which I was explaining, can be used to through the eye you can see, through the minimal residual power you can activate and activate the system. Myo armbands, like kind of the gesture, kind of like this wearable S surface EMG based armbands we use here with a different kind of gestures. So like you can do the fist, so you can turn on, turn off. Then we use with the interface like 1 finger, 2 fingers kind of motions. Then we implement the application, which is like first we implement for the Latin script, then we come to the Hindi and Bangla and other languages because of the need of this. Do you know how many of the, like in terms of the language, how many of the or approx user for the Latin script, Latin English language speakers, and how many Hindi language speaker across the globe? Don't do the Google. Just tell me the guess. No idea? Any idea? So there is not much difference. So 400, this calculation is 2 years back, maybe a week, something is changed. But like around 510 million user for the Latin script, whereas 490 million user for the Hindi, which is the like language, official language of the India. Then we thought, why for the low resource setting languages system should not design. So therefore, like I'm putting this concept here. Other things in this concept also, when you design the systems with this low resource settings and which can be controlled through the eye or brain signals and this, then because we have a number of letters more than the 70 to 100, including diacritics, consonants and all, how you can put all those things together. Let's say if in mobile application, I want to develop that, how you can put that. So we have used just a tree based mechanism. So this speller can be go in the tree level. Doesn't matter whatever number of command. So here it work in the 2 level. So in the first level, so only the 10 box, and which was thought through to design for the usability of such system. Let me. It was thought through to design the usability of such system for the small screens. Okay, so then it in the first level, if you can see, if I click on this, then it will open in the second level this, and then you can select it can be typed. Okay, this is the concept of that, and then the mechanism which we have developed, we have introduced here, and then I will present you the some of the results. This is clear to everyone. So how this is working, and this is easy to follow. It's like all the letters where it is coming here, then there is a symmetry. So you already know 10 boxes. So this will come here. The first 4 will go in the sync. Bottom 4 will go in the sync, and this go in the sync. So in every buttons it's a symmetry, and then we have tested with just a new or beginner user just one time. But like if such system can be tested for the longitudinal study, then definitely the performance will be increased, because like after seeing that kind of system, using that kind of system, you practice, correct? So you'll see, then we have designed the 4 different experiments. Experiment 1, where we wanted to compare the mouse versus touch screen performance. In experiment 4, we wanted to confirm the eye tracker with soft switch versus eye tracker with EMG, the surface EMG different gestures. In experiment 3, fixed versus adaptive dual time in synchronous, and likewise in experiment 4, fixed versus adaptive trial period in a synchronous, correct? So these were the like, so here you can see these are the results in that way. So you can see here in the, I have just put the average speed letter per minute, but the paper is here. If you want to go, you can see the other results in terms of the ITRs and all, which will help you to see the broader perspective. So here there are the 24 participants, which was the healthy participants, in fact. So first design the technology used with the healthy participants, and further we use this with the stroke patients and mobility users also. So first let us come with the healthy one. So 24 participants here which we have used, an experiment I have explained. So here you can see, this is the just a finding. In terms of 3 key things which we can see when we did the touch is this soft switch, which we have reached to the like around 24 letters per minute in typing of with the typing speeds. When I am comparing with the adaptive dual time and non-adaptive dual time, so you can see the top speed crossed all the dual time. So we took the dual time 1, 2, 3 in the gap of this, and then interval time, and then define these methods, and you can see these provide the highest typing speed compared to the non-adaptive, which is significantly achieve the performance. Correct? And then further to evaluate this, not only just like a matrices which we are using, but to evaluate this, the usability, you can say subjective evaluations, the matrices which was used is like how you can see, this is called the NASA workload test, which is a very well defined text to check the workload of any application which you have designed. So like when the user is using, then what is the mental load, physical demand, temporal demand, performance, efforts and frustration. So we have found the workload is less, and then system usability score, which is called the SUS, which is the higher. So which shows the usability of that applications is good or should try in that direction. Okay, it's clear to everyone? Okay, let me now on that transfer to that. Now I'm switching quickly. Context is already set. So in other work, we thought like where we should put this in a GUI, how we can optimize these keyboards, and where this particular letters which I am putting at this location, why at that location should matter. Correct? So then we developed the optimized GUI method, and what it does we get the probability of all the characters and then like occurrence of the characters, and we did the one test trial with the multiple users like and then from that test trial we have identified this is a 10 by 10, so we just designed the 10 cross 10 matrix. Okay, so 10 cross 10 matrix, and each box, each point should have a time. So let's say during the experiment, because we have a 10 cross 10 matrix here, so during the experiments, how many time in each matrix points user stayed there. Correct? And based on that, we have identified this box require the less time to select. Yeah, this so box, it means 10 cross 10 matrix, it means this whole screen divided in 10 cross 10. Correct? Simply, whatever the computer screen, big screen, shorter screen which you are using. And then we know now these points which require the less time. Then we got the corpus of the Hindi language. Right now, like you can find the corpus, but at that time, like we combine the books and do this letter frequency and word frequency and wrote the codes in the MATLAB. Correct? We defined that thing, but now you will get this word frequency, letter frequency for this. So in this paper also you can see, if you want to see in the depth, then we took I think around 1 lakh, 1 million kind of the characters to find out that. So then based on that we got the time. Now what we need a letter of frequency. So we thought like where the frequent letters should go. Correct? So maybe it can go to the less time, most frequent letter. So we designed the kind of the different arrangement of the GUI. So I'm not considering that, but like you can go in depth, check. So now these are the 5 different GUI we designed and follow that methods which we propose, optimize graphical user interface for this. So the first alphabetic organization with script specific arrangement. So what does it mean by that? Alphabetic like in the language, and script specific because in the script what we have, we just follow that arrangement. Frequency and time based. So the things I was explaining, the less frequency and time based approach. Frequency and time based with script specific arrangement, because this alphabetic organization, it means like you know this first letter will come first. Other script specific organization, like the most frequent letter will come there. So you will see the all interfaces in there, and then we randomly put. So randomize the all frequency and this, randomize all things, and we implement all interfaces. And then test that methods which we have developed with the eye tracker and eye tracker with soft switch with the healthy users. So here you can see this frequency and time based adaptation with a script specific arrangement is like the accuracy you can find which is the higher. So it means like that matters to design the interfaces. And then further we tested it with the stroke patients, 10 stroke patients in the hospitals to this system, those who cannot speak. Then they use this tool to talk and the task which was designed. So again we have found like even though the performance comparison with healthy and stroke patients is less, because like they cannot focus and they type less, because due to the at that time they have this kind of the disabilities with the speech or motors, or you know, so their mental and temporal demand is always be higher. So but they can use this and write some things to talk, which is like matter for them, because they have only the one mean of the communication. Okay. Then further these technologies we developed and we transfer simply this for the dyslexic children's from strokes to and what we are trying to do here, first the task which we developed this in a way, now when the user will type, then because dyslexic children, what problem they have a mirror problem, reading and writing deficit, correct? So then we design a tool, same tools, but we design in this way, then with the feedback mechanism. So like it means if they are seeing, so mirror problem, it means they cannot differentiate ba or wo. Everybody can understand this in Hindi later, no? Okay. So because it's very difficult to differentiate for them, and likewise other letters. So we did experiment and design in a way, then this tool is helping them to correct. So it means they can also see the red border and the systems. If I'm looking at here, oh no, this is not correct, but they are seeing on that button, and then we record in the log what they were doing, everything, and then we analyze that data to identify how this tool can be used. So one way we use this for this tool, this system for them to do their kind of the communication tools as, and other things by their patterns we have identified using the different state of the art machine learning algorithm classifiers, and we identify based on the typing pattern these children could have a dyslexia or not, correct? So we tested this with the school going children's and then with dyslexic children's in the centers. So I will present some of the interesting findings here. So here in this you can see two things here. One is VCI and PRI. So what is this? These are the verbal comprehension index, VCIs, and PRIs. So verbal, basically we use the similarities, vocabularies, and comprehension information and word reasoning. So there were the task was given to them before this, and we checked their reasoning and these things by using the VCI index, and then we check this PRI, perceptual reasoning index, with the like block design, picture concept, matrix reasoning, and then kind of the picture compositions kind of the task. And then we got their score, all the kids score based on that, and based on that we identify if the score is this much less, it means they could have a this kind of the intellectual disabilities, and these were the key terms are very well defined in the research in the. So we took this here, and then First, we did the analysis in the same way which I have explained you in the eye tracking this with the modality level. But we check interesting things with the VCI. If let's say this VCI index and PRI index is less, then what is happening first? So, and you can see in the results, if the person is intellectual disabled, their performance of typing is also less, which you can see. So, it means like that could be the digestible and understandable, correct, in all the things. So, if the PRI score is higher, then definitely their typing speed is higher in the both cases. Then this was the like for the I would say typing speeds performance results. But now here in this we have a like in study we took the 16 dyslexic and 16 control group, okay, and then based on that 31 we mix up and use the 31 to train the model, and then we have evaluated that with all the users, and we have model could identify, and here you can see the different classifiers which we have used based on typing pattern if these children could have dyslexia or not. So which is like the good to have such kind of the low cost technologies. So let's say if you are doing some work, but also technology can help you to give you the kind of the not I would say the screening tools kind of things you can say, correct. Further, recently one of my student is developed this. So master students, he is in TCS right now. So we designed this flex tree. So what we did on top of this, we use the prediction model to improve the speeds. So there are adaptive rules, but text predictions. So nowadays, if you talk about the recurrent neural network based models like LSTM, BLSTMs, you could use N-gram models kind of things. So two things. One is a statistical model. One is the deep learning based models for the letter prediction, next letter predictions, and also what are the other recent things which you could think for this prediction? LLMs, correct? So that could be the integrate with such kind of the systems to boom the speeds and all. And recently one of the like the papers I was reading 2 days back only, it present in a what is the nature communication, and they have used the LLM to integrate with this typing kind of the interface for the, and they have tested with the ALS patient in the hospitals. And so this is a like kind of speeds which they got like with the LLM. Only the thing is that it cannot be deployed with the less parameters, correct? But now the other venues has come up how you can design the offline AI models to do some kind of things, correct? But so coming back to here, so what we did in this predictive kind of the model, so PPM based models which we have built and algorithms built, and there was one of the very famous this Dasher keyboard. So this Dasher keyboard is designed by the Cambridge University, okay, and this was the one of the great keyboard for the typing and got very good speed. But in this results we have found when we integrate, so we reproduce that, and they help us to give the whatever the things were available. We reproduce that and we developed our things, and then we have checked like when we integrating with the eye gaze, this couldn't be performed very well, and then error rate is higher for the corrections. So here you can see, and we did this with the different kind of the handcraft like sentences, and with the random pick sentences. So random pick like out of the dictionary, and one is handcraft from the dictionaries we pick, and then here you can see the speeds can be improved. But other things you can see the deletion time in a flex tree and Dasher flex tree we call like tree based, and that That is why we call the flex tree, which is the less than that. And then here also the speeds you can see which we can achieve till that level. Okay, so 27.5 and this was the mechanism how we implement that. So ppm is a method, correct, and this is the interface. But now how you can make the techniques to integrate them. So everything we do have like models, LLM model, machine learning models, and rule based model, but how you are using and how you are integrating them. Correct, and this could be the scientific contribution, and it was therefore it published. So now I can show you little bit. So I think I have talked a lot, but we still have a 5-10 minutes. So here the keyboards which I was explaining to you. So you will see and how it works. So in this video, the first one I will play. So bear with me. So in this, it is working with the eye gaze tracking only. So here is the eye tracking device. So this was the eye tracking device which record your eye gaze, and then this was the interface. So user is looking, as I was explaining to you, this red, it means your pointers. So look at that pointers. Now border color will be darker. So then you can see your intention to look there is very high, and then based on that it can select, it can type. And this is the kind of like a text box, and then you can save this. You can type in any platform. And then the task, because like we wanted to see, therefore we define the task like this: kab tak jab tak abhyas karte raho, and numbers, some numbers which we gave. And why we designed that task? Because that task include all the commands, or I would say all the boxes equally probable. So it means like the task is not biased. So it means during the experiments you have revisited all the buttons. So therefore we design in that way to the system. Okay, and it has like all things like in Hindi we do have half letter. So how the half letter can be written, so that is the method for that. And then further, this was the things when we use this with the dyslexic children. So we redesigned that in a different way by integrating the different mechanism. In this, you can see how the user is using with the eye gaze. Here, this was the video of the dasher. So in dasher, what happened when you are moving your mouse, the select it will come like in a letters will moving like you can see in the screen. I will play, and then it will go in the region. It means like it's selecting. So it's very zig 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 zig, very fast. So you can use the mouse pointers there. But for the gaze, it's a little bit tricky when you have a mistakes. Then you need to move and go back again. So error rate will be very high. So we compare and we did the test with this. Here, when I'm talking about the integration with the different modalities, so we did integration with the, like in hands, you can see this is the surface EMG sensors, where user is looking at a screen. So it was the hackathon where I participated in and I took the videos there. So user is looking, and through double tap, single taps, you can select that, and with the easy also.
Over email or push it onto Bernard's GitHub, so the jury can look at it and decide to see who gets the best score, and then you get the prizes shipped.
Okay, so let me next. So currently it's in the 3 languages, full-fledged is this available to use. So now we are also working towards to that, like our tools which we can make accessible to the user on our websites. So then they can use, anybody can use that and in the daily living activities. And for like if you want to develop some things and then you want to reproduce, then the code base is also available and things are available for accessibility. So further, just conclusion, just two slides. Is that be okay if I can take 5 minutes? Okay. So further, now you can see the how we could transfer the technology. So as we were started with the communication and then mobility. So similar concept in terms of the UI. So you can see here. So here is a 9 or 10 commands on the screen, correct? So instead of typing a character, I'm using is for the control environment. Correct. So control the car, control the wheelchair or anything like in that. So we just translate that in that way. So how it can be facilitate the multimodal facility, how it can be integrated. So simply for disabled users, we integrate with the wheelchairs, and then where we integrate with the different modalities which we have tested already, which were feasible. So like here we did with the just touch and then eye tracker for the synchronous dual time based, and here with the short switch. So 3 modalities when they drive, and then we try to integrate and test it in the real time wheelchair. So here we did the like test. So here is the paper, you can find the some of the results. And then further we also thought like if it could be for daily living activities, then how it can be useful or transferable. So we use the this portable hand exoskeleton which we designed. It was designed under the UKRI project from the IIT Kanpur, where I was working over there. And then we have integrated that with the, basically it was designed for the neuro rehabilitation. We did some work, we used that, but we integrate that with the wheelchair also. So while the moving, if somebody want to grab some things like you can say hold, grasp and release kind of the moment, just simple moment, then they can do if it is integrated with such kind of the systems, and then we tested it with. So here you can see. So like this is the laptop or the wheelchair panel. So we design it in this way. Then user can look at there, and then these directions can be used to select. So it switch panel. So if you are looking at that, it can switch and open the control panel, and then where you can do this hold, grasp and release. And again, if you want to go to the direction, you can switch back to the direction and you can use that in that purpose. Okay. Okay. So yeah. So these are the, I think I was thinking like instead of presenting just the work, if I can give you some direction. So I just thought through, and these are the, I think, very good opportunities for the innovation. So if somebody is interested in that, so like innovation, very good opportunity. It means like still open source accessibility tools need to be built or still very limited. So this could be the one direction to work on. And multilingual lingual voice interface kind of the things which could integrate with them to make more refined. And as I was saying, offline capable interface like AI models should integrate, which could go to the hardware level. So like how it can compute on the low hardware device. And smartphone based accessibility apps could be the another avenue where these methods and systems can be used for the different purposes. So I thought like this would be helpful for you. And I just want to acknowledge the these funding project which help to build all those tools which we have till today. So like UKIR, UKRI projects, and then IIT Kanpur Global Challenge Research Fund from the UK Research Council, and St. Andrew Mobility Awards from the EU. So if you want to see some latest news or what is going on these directions, then you may follow the lab page on the LinkedIn. So this is the QR code for that. And if you have any doubt or any question, so you may email to the lab email address, or you may email to me. So I will try to help, and I will try to respond. Thank you. Is there any question? Yes. Very good. So I have used a range of the eye tracker so far. So the lowest eye tracker device which I used, it was like 100 USD. But now that company is acquired by Facebook already. So okay, so it was the Tobii eye tracker device which in the beginning. Then Arrington eye tracker device I have used. Right now, not Tobii, it was the iTribe, the company. Now I'm using the Tobii, which is the one of the big company, those who are doing this eye gaze things. So, but which is costly in compared to 100 USD device. So other things also you could in eye tracking there is two different aspects of using the device and their costs. So like if you want to use just for the fixation, so XY coordinate to actuate, then you can use the low frequency eye tracking device, so which is the very less cost, so 30 hertz to 60 hertz or 120 hertz kind of. If you are going higher the frequency, it means like the cost will be, because high efficiency cameras and algorithm is required to process them. Okay, so but you could use we have done some of work which I have done, put it here. Now we are still working on to use the just these VG cameras and normal cameras kind of things. Okay, which give the 30 hertz frequency, 28 to 30 hertz frequency, which we have validated.
That is good if we are able to. Like that is good if we are able to use the camera of like.
That is good, but it requires you to implement the. If you are using classification based models, then you need to implement that in a way how the model can be trained and used for the different data or different users. Or if you are doing regression based, then also you need to think about it. So like I would suggest check the this iPhone function which Apple put eye gaze tracking in that. So check that. You will see some of the interesting things, but still there are a lot to do to make it usable.
Thank you, sir.
Yes.
Sir?
Yes.
Yeah. When you showed the study with dyslexic children, I want to ask, were you using the classification of SLD and ID mutually exclusive or overlapping?
Overlapping.
But they can't be.
Why?
All the diagnostic classifications and clinical psychologists function on the fact that if there is ID, you cannot give a comorbidity diagnosis of SLD.
Okay, so this was the overlapping. What I meant for that, to train the classifier model, correct? So overlapping, it means like both the group could be overlap to design the model. Is that your question?
I meant like like which part of the study was done with SLD kids and which part of the study was done with ID kids, because their entire experience with the experimental paradigm will be very different. So ID is different. There is global cognitive deficits, whereas SLD is very specific to the structured education system.
Yeah, so we did, yeah, okay, now I got it. So not model level you're asking. So we did with the reading and writing patterns only. So reading, and because like we wanted to just check the reading and writing patterns of the children's. So the study was done in a way. The first study, we intervened the students from the schools, and then we did this Wix text. I think you are going to more neuropsychological perspective, correct? So we did the VCI and PRI. So there were the like psychological people from the Kanpur, they were involved in that, and then we had a one research assistant, she did collected the data. So then once we got that data, then we have identified this was the score. Now we could do this is a particular control group, we could do the study with them. And then other study which we did, so in the control group, it means the age range we took the same. So like we took like 5 to 16 or 5 to 14, something like that. And then other control group we just did in the dyslexic centers. So it was not like we have intervened and tell this could be the dyslexic persons, you know. So they also had their scores, and based on their scores and based on their recommendations, we took them. But we have get all the scores VCI and PRI, which we did with the healthy from that perspective.
So my main question was out of personal curiosity. So there are grades of SLD and ID. To what grade this assistive technology was able to actually assist? So after a particular grade, no such technology is going to help them.
Yes.
So I want to just
So
ask
grade, it means like a school level?
No. Grades like in ID, there is mild, moderate, severe, and profound.
So okay. So we use yes, that's a good question. We use those who are school going kids.
Okay, till mild.
Yeah. So
Okay.
school going, it means like it's a mild to moderate.
Yes.
Okay.
Okay.
Yeah.
Thank you, sir, for the insightful talk. And I wanted to inquire about how do you see these assistive technologies are adaptive in nature, particularly while considering with the human in the loop studies. How fast it is adaptive in nature, these technologies with the studies. And the other thing, while dealing with this eye gaze, normally our eyes suddenly switches the fixation point.
Yeah.
We kept on looking, but our intention may not be there. So how do you consider these points while considering these things?
Yeah, that's. So as I explained the Midas touch problem, this is called the involuntary eye movements, which you are explaining. So for that, we have developed these adaptive models. So it means like if your eye gaze is very much fluctuating, then it means you cannot type, or you are having the difficulty to concentrate that particular button or that particular box. So you may need the more time. The system may see your behavior and improve the time for you, correct? So therefore we develop these methods. So this is the first thing. And second thing, how you can encounter that other things. So we have incorporated the multimodal facility or hybrid facility, as I was explaining from the BCI perspective to the input switch and SEMG. So where, because I fluctuate very fast, and therefore this problem may occur, but you can look and select through the different input modalities. So then it means like involuntary eye movements kind of the things you can resolve or overcome. Like it's not completely we cannot resolve, but according to the results we have found, putting the input modality, multimodality will give the better results. Okay, and no question. Thank you so much. Thank you guys. Thank you.